Lesson 5.8, we are going to discuss special right triangles. And by special right triangles, I mean right triangles that we see occurring frequently. And so I'll ask you to take a look at the diagram at the top of your page and just think about if you were to classify that triangle. Well, we would classify it as isosceles right triangle. And this is actually happening when we had a square and we cut through the diagonal. Right? If we had a square and we cut it down the diagonal, we'd end up with an isosceles right triangle. And because we know the base angles are equal in an isosceles triangle, if it's also a right isosceles, we are always going to end up with a 45, 45, 90 degree triangle. And that's one of our special right triangles, 45, 45, 90. Now they have our sides labeled as x. Here my two legs are congruent, and my hypotenuse as y. If we just take a look at how x and y kind of relate to each other, we know that because it's a right triangle, we can put that into the Pythagorean theorem. X squared plus x squared equals y squared. And I actually could do a little bit of simplifying to that. I can add my x squareds together. 2x squared equals y squared. And I can even take it a little bit farther. I can say, well, what if we looked at the square root of both of those? I can take the square root of x squared. I get x. And I'm going to leave that as radical 2. The square root of y squared is y. So what this tells me is that y is equal to x times the square root of 2. And that is always going to be the case in a 45, 45, 90 triangle. My hypotenuse is always going to be equal to the leg times root 2. Now root 2 is about 1.4, but because that's approximation, we are going to work with the radical form, so we're going to leave it as the square root of 2. So what we're going to talk about today is we're really going to talk about some ratios that are true in these special right triangles. In a 45, 45, 90 degree triangle, both of my legs are congruent. And here they have them marked as L and L. The length of the hypotenuse is the length of the leg times root 2. So what that is saying is h, my hypotenuse, would be equal to L times root 2. Now, let's put some numbers to that. Let's just say that my length of my leg was 10. My other length would have to be 10. Well, that means my hypotenuse, even though I could figure that out with the Pythagorean theorem, I actually kind of have a shortcut. I know that the hypotenuse would be the leg times root 2. So this would simply be 10 root 2. Now, we could figure out that calculation, but the 10 root 2 is an exact answer. So when we take a look at solving this today, we're actually going to look at finding our missing sides of our triangle, but we're going to leave our answers in radical form. First thing we want to identify is what kind of special right triangle we have. If this is 45 degrees and this is 90, we know that this is 45. We know that our two legs would have to be the same. What would my value for x be? Well, if this is 6 and this is 6, x would simply be 6 times root 2. Now, 6 root 2, we could figure out that value by multiplying that. It actually comes out to about 8.5, but we're going to leave our answers in radical form today. If I take a look at number 2, and I'm solving for x, well, if these two legs are the same, this must be a 45, 45, 90. My leg is 9 root 2. Well, I know that my hypotenuse is longer, and so how much longer? Well, I need to take 9 root 2 and multiply by root 2. Now here we're going to get a little work with our radicals in. If I take 9 root 2 times root 2, we are actually going to have just 9 times 2. In the end, we would find out that our hypotenuse would have a length of 18. So root 2 is kind of our magic number for these 45, 45, 90 triangles. Really, you just need to ask yourself, is the missing value longer or shorter? That would tell you you're just simply deciding if you multiply by root 2 or if you divide by root 2. As I look at number 3, I notice, well, 45, 45, 90, that my value for m and my value for n are going to be the same, right? M is equal to n. Well, this time we're working backwards a little bit. My hypotenuse is 7. If my hypotenuse is 7, well, I would have my leg 7 equal to m times root 2. But I want to know what m is. I want to know what that value is for my leg. And so in order to get m by itself, we're actually going to divide by root 2. Okay. Well, we know that having 7 over root 2 being equal to m is not really an acceptable way to write our answer. We actually need to rationalize our denominator. So in order to rationalize my denominator, I'm going to multiply both the top and bottom by root 2. And when we do that, we end up with a whole number on the bottom of our fraction. So we do that, we end up with root 2 times root 2. Well, the bottom of my fraction would give me 2. On the top, I would simply leave that as 7 root 2. Nothing simplifies, nothing reduces, and so this is my value for m, my side length, 7 root 2 over 2. Now, this is what m is. It's actually also what n is as well. Let's look at number 4. On number 4, I can see that if these are x and x, it's isosceles. So this must be 45, 45, 90. My hypotenuse here is 5 root 2. This is actually going to be similar to what we just did. We're looking for my value for x. Now in this case, my side length is going to be smaller. I know that x times root 2 equals 5 root 2, my hypotenuse. My side length times root 2 equals my hypotenuse. However, when we go here and we're going to get x by itself, if we divide both sides by root 2, well, root 2 divided by root 2, these divide out, and so my final answer, my side length, is just going to be left with 5. On number 5, 45, 45, 90, I know that this must be 7 root 2. My two legs are the same. Now I'm going to approach this one a little bit differently. I'm just going to think, well, my hypotenuse would have to be longer. If something is longer, to make bigger, we multiply. So if my magic number is 7 root 2, I know that my hypotenuse here, 7 root 2, I can just multiply by root 2. Well, this would really give me root 2 times root 2 is a 2. And so in the end, we end up with a hypotenuse of 14. So I think it's easier just to think about whether you are multiplying by root 2 or whether you are dividing. In number 6, I have my 45, 45, 90. I can see that if this side is x, this side would be x. My hypotenuse is 18. So the side length of my triangle, well, x would have to be equal to 18 divided by root 2. Now again, that's not left in proper form. I need to rationalize my denominator. When I do that, I end up with 18 root 2 all over 2. But in this case, I can do a little bit of simplifying. 18 over 2 does reduce, and so I know that 2 goes into both of them. 9 times 1 time. We're going to leave our final answer as 9 root 2. So that's our 45, 45, 90 triangle. If you flip your paper over, we also have one more triangle to talk about. If you look at the top, you can see, well, this is actually an equal angular and equilateral triangle. So all of my angles are 60 degrees. But I actually want to take a look at what happens if we split that right down the middle. Okay? If I split that, I actually end up with a 30, 60, 90 degree triangle. So I'm going to look at just 1/2 of this equilateral triangle. And let's just say before that the sides of my equilateral triangle all had a measure of 2x. Well, if I split that, then this side down here, would you agree, has a measure of x? And let's just call the height of our triangle y. If we take a look at the relationship between x and y, first of all, I notice that this small part here, and what would be my hypotenuse, if this is x, this is 2x. That is double the length of this. That's always going to happen in a 30, 60, 90 triangle. And I also could think about, well, Pythagorean theorem applies here. If I took x squared plus y squared, that should equal my hypotenuse squared. I could simplify a little bit. X squared plus y squared would equal 4x squared. And if I wanted to get my x squareds on one side and I subtracted it over, we'd actually end up with y squared equal to 3x squared. One more little simplification. I could think about how y compares, taking the square root of both sides, y would actually be equal to, well, the square root of x squared is x. The square root of 3 is not a rational number, so I'm going to leave it as root 3. But this kind of shows the relationship between x and y. Y is equal to x times root 3. Now, root 3 is about 1.7, so what that tells me is that y is about 1.7 times longer than x. That is always going to hold true in a 30, 60, 90 triangle. Okay, so a 30, 60, 90 triangle is what we get when we split our equilateral, and the ratios that hold true, and says that the length of the hypotenuse is twice the length or double the length of the shorter leg. And the length of the long leg is root 3 times the length of the shorter leg. So as I look at my picture over here, my shorter leg is s, my hypotenuse is 2s. My shorter leg here is s, my longer leg would be s times root 3. What would that look like with numbers? Well, if I said my shorter leg was 6, my hypotenuse would have to be 12. It's simply double. My long leg is going to be about 1.7 times bigger. So I could take that short leg and say it was 6 root 3. Now that really means 6 times the square root of 3. If I took 6 times the square root of 3, I'd end up finding that that's about 10.4. But again, we're going to leave our answers in radical form today. I want you to work with those ratios. The ratios are meant to be a shortcut. Even though it can be a little bit cumbersome in the beginning, it's meant to be a shortcut. So as I take a look at number 1, I see that I have a 30, 60, 90 triangle, and we're going to try and identify our missing sides. Here I'm looking for x and y. Well, if my shorter leg is 21, the very first thing that I do is I look at my hypotenuse. This would have to be double that, right? And so x is going to end up as 42. my longer leg is just s times root 3, or my short leg times root 3. And so we would write y as 21 root 3. And those would be my missing sides. Okay, now that one was pretty easy because they gave me the short leg to start off with. As I look at number 2, I can see, well, they don't give me the short leg. They actually give me the hypotenuse. My hypotenuse is 10, but I'm going to first then find my short leg because I know that it's half, right? So x here is going to have to be 5. Once I find my short leg, I know that this is simply times by root 3. And so my long leg would be 5 root 3. Now, on some of these, once you have found one of the missing values, you can use the Pythagorean theorem. Because it is a right triangle, using the Pythagorean theorem would result in the same answers. Number 3 is a little bit trickier. As you look at your given information, you have to decide what leg they gave you. Here they gave me the long leg of 11 root 3. So if my long leg is 11 root 3, I'm going to kind of work backwards here. My short leg, 11 root 3, we'd simply divide by root 3, and we would find, well, that short leg is going to be 11. I'm going to find my short leg first. Then I'm going to take that and find my long leg, which would be A, and we're going to double that. In question 4, again, they give me the long leg. But this time, they're saying my long leg has a value of 12. I'm going to find my short leg. If I were working backwards then, I would be taking 12 and I would be dividing by root 3. Now, 12 divided by root 3 is correct, but it's not written in proper form. So I'm going to have to go ahead and do a little bit of simplifying. I'm going to rationalize my denominator first. I'm going to have 12 root 3 all over 3. And then I do see that I can do a little bit of reducing. 12 over 3 reduces. We're going to call that a final answer of 4 root 3. So my short leg, x, is 4 root 3. What about my hypotenuse? Well, I know my hypotenuse is when I double that. Well, doubling means times by 2, right? Can you take 2 times 4 root 3? Yeah, we talked about that last time. You can just multiply your whole numbers, and that would end up giving me a final answer of 8 root 3. Looking at number 5, this one's going to be similar to what we just did. I see my side lengths where 7 is my long leg. Now I should note, how do we know that? Your long leg is always across from your 60-degree angle, and your short leg is always across from your 30. So if I need to find my short leg, I'm going to think about taking 7 and dividing by root 3. But again, I know I can't leave my answer like that. I need to rationalize that denominator. In this case, I end up with 7 root 3 all over 3. And I can't reduce or simplify, and so that's just going to be my value for x. Even though it's a little bit ugly, that's how we're going to leave it. Now my hypotenuse is double. Can I multiply that by 2? Yes, we can. Multiplying it by 2, well, if you remember, multiplying fractions, 2 is just 2 over 1. And I'm going to multiply straight across. And so my value for y would end up being 14 root 3 all over 3. Final answer. Last one. In question number 6, as I look at finding my sides A and B, I can see that the given information, my hypotenuse. So if they give me my hypotenuse 2 root 2, I want to think about finding my short leg. Well, my hypotenuse is double my short leg. And so 2 root 2 divided by 2 would give me the value for my short leg. Can we do that? Sure. The 2's are going to cancel or divide out, and my value for my short leg is just going to be root 2. So I know that B is equal to root 2. What about my long leg? Well, my long leg is simply short leg times root 3. This would be root 2 times root 3. Can we multiply those? Yes, they're both radicals, and so we would say that A has a value of root 6. And those would be my final answers. Now I know simplifying these or solving the values for these special right triangles can be confusing at first. It does get better the more familiar you are with the ratios and also the more familiar you are with simplifying radical expressions. If you have questions on this or you want to go through more examples, please come in and see me.